Right, hello. So today we're going to have a look at the equity or the equality, for want of a better word, of complex numbers. So to put it into the kind of easiest kind of parlance, imagine you have an expression that looks like this: x plus, um, let's say, 2y I equal to 4 plus 6i. Okay, and you're asked to solve for x. Solve for x and y. Okay, so what you have to understand with this is that what you're really dealing with here is two separate equations. So the first thing I would do is I would identify the real part to this equation. So this part is, sorry, I'm going to use a different color that actually shows up here. Let me see. Yeah, maybe this one here. So that's real. That's not real. There's an imaginary number there. This is real. Okay, and obviously then these bits are imaginary. And the idea is to separate out the real from the imaginary. So that's what I'm going to do first of all. So I'm going to keep everything where it is, except for the real side of my equation, I'm going to imagine that the imaginary bits don't exist. So we just have x equals 4. And then for the imaginary side of my equation, I'm going to pretend that the real bits don't exist. So I have 2yi equal to 6i. Now, this can be solved. Obviously, if you had a coefficient of x, you just divide across by the coefficient and solve it, but it's solved already, so x equals 4. Now, this looks unsolvable, but what did we say about I? Remember, I is the square root of -1. So if both of these are multiplied by the square root of -1, in other words, they're both multiplied by I, then would it not also be the fact that if I divide both sides by I, I'm just left with 2y equal to 6, y must be 3. And there I've solved my x and my y. So it's a very important concept, this idea that when you have a mixed sum, where not only do you have real and imaginary, but you have unknown variables, that you can solve them by separating the real from the imaginary, or to put it into a kind of a more easy way to remember, real to real and imaginary to imaginary. So if you follow this kind of mantra, keep the reals to the reals, the imaginaries to the imaginaries, and then solve them as normal. Because when you have all the imaginaries together, because they are all imaginary, it's actually the same as if the imaginary part of it didn't exist. Because it's common to everything, you can just divide it out. So we'll try another one of these just to kind of get your head around the concept of this. Hopefully you'll get your idea of this one. It's a nice, easy enough idea. Okay. I'm just going to adjust the light there. So here's a kind of a bigger version of the same idea. Okay. So imagine we have x. Again, we're trying to solve for x and y. X plus 2i plus 6 minus 10yi equal to 8 minus 13i. So first things first, real to real. I'm going to identify all my real bits. That's real, and that's real. So now they're going to go to the real side. So I have x plus 6 equal to 8. And now I'm going to identify my imaginary bits. And they're going to go to the imaginary side. So I have 2i minus 10 yi equal to minus 13 I. So let's solve this side first. I'm going to subtract 6 from both sides. And there's my answer. And on this side, I'm going to pretend, look, everything has an I. So that's the same as this sum. There's no difference between them. So if that's the case, I can take away, let's see if I'm trying to think, I can take away 2 from each side and divide both sides by negative 10. What's that? It's going to be 3 over 2, isn't it? 1.5. So you see here, even when it's more complicated, so long as you can extract the real, extract the imaginary, it'll work out. Okay, so it's a very nice one to be able to do. Okay, we'll try another one. So again, all these cases, what you're trying to get is the real and the imaginaries away from each other. So here's another example. Let's try and think of another one. Right, let's say you have p plus 1 multiplied by 2 minus I equal to 3 minus 4i. And I want to find p. Find p. All right, let's have a look at this one then. So if I want to find p, I'm going to have to get p on its own. So I suppose the first thing, there's a multiplication. In order to get at least this bit on its own, would it make sense to divide both sides by 2 minus I? So let's do that. Now we're into our division, which we've done before in a previous video. So we're going to do the division in a second, but can you see what's going to happen here? This is going to generate a real bit and an imaginary bit, okay? But because we only want one possible answer, our answer should be a complex number, but we'll see how we go with it. So let's take this side and divide it, okay? So how do we divide it? Well, let's do it out here. 3 minus 4i over 2 minus I. And remember, we multiply top and bottom by the conjugate of the bottom. Now, we have a trick. So we do. We have a little trick for this. Square both numbers and add them. 2 squared plus 1 squared is 5. And then we're just going to have to do this out. We're just going to multiply this out. So let's use our little grid. We have 3 minus 4i. And we have 2 plus I. And what we're getting is 6. We're getting a minus 8i. We're getting a 3i. And 2 plus I, yeah, that's an I. And then we're getting, now here, remember this is our little trick. We have a minus 4 by a plus 1. That's a minus 4. But I squared is minus 1, so that changes that sign. Okay? So, to a plus 4. So, let's add. We've got 10. And we've got minus 5i. So, this is what it looks like. Of course, we know what that becomes. 10 divided by 5 is 2 minus I. So now we have p plus 1 is equal to 2 minus I. P is equal to, subtract 1 from both sides, 1 minus I. The difference between this and the other one, there's no variable attached to any of the i's. So I don't have to separate a real from an imaginary because there is no variable. There's only a variable and it's not attached to the I. Now, it would be attached to the I if I tried to multiply that out. But in any type of manipulation where you're trying to get a number on its own or a variable on its own, you never multiply out if you can divide out in order to separate it from this side. So this one's a bit more tricky. But this, we're using the skills we used before. We're using our division skill here. Okay, so we can try another one. This one, next one, is one that has come up I think very recently, I actually think this came up on 2021's, adjusted Leaving Cert paper. Okay, so, and all you were asked to do was, let's try and think. I think it was find A and B. It was something like find A and B in the form of A plus BI. And all you're given is this. Okay? That's all you're given to work with. Now, obviously, there's an A, there's a B. The problem is this is in the way. So this has to be gotten out of the way, for want of a better word. Okay? So let's see how we do that. Well, if I want it to be in that form, then it would make sense to make it equal to that form. That allows me to square both sides to remove this root. So we're going to square both sides. When I square this side, the root just disappears. But that's now going to be equal to this. Aha. So let's see how we can do this. We're going to have to square out this. Now, there's multiple ways you can do it. You can use your little grid. Or you can just, but the fact that we're squaring the same thing, we can use my little trick. Okay? Square the left. Square the right. What's b squared, I squared? Yeah, you're right. That's minus b squared. And then multiply them together, ABI, and double it. Now let's have a look. I see real and I see imaginary. Okay, so let's get the real and the imaginaries together and see what we can do. Okay, so the real bits, we have 5 equal to a squared minus b squared, and then the imaginary bits are 12i equal to 2abi. Okay, so this can be obviously changed into 12 equal to 2ab. Now, what I'm seeing here is I'm seeing the beginnings of maybe some type of substitution. So let's have a look at this. So again, I'm reminded this was from this year's, I was in 2021's paper, similar idea. So let's manipulate. I can divide both sides by 2. So that's 6 is equal to AB. And then A is equal to 6 over B. So I'm going to substitute that in here, and we'll see where we can go with it. So I'm hoping you can spot that. So if I substitute that in there, that's going to be 5 is equal to 6 over b squared minus b squared. Okay, so let's try and think. Let's do some cool things here with this, I suppose. If we multiply everything by, trying to think, that's going to be 36 over b squared. Let's see it. 5 is equal to 36 over b squared minus b squared. If I multiply everything by b squared, I'm going to get, let's say 5b squared, 36 minus b to the power of 4. Let's get them all together, see what we can do. Okay, bring these over. So we're going to have b to the power of 4 plus 5b squared minus 36. That looks doable. A b squared by another b squared. I need to get a 5, so it's a 9 and a 4. A 9 and a 4. And I need a positive 5, so a plus and a minus. So that is solvable. Hope you can see that. That is solvable. Okay, so if b squared is equal to minus 4, that means b squared is equal to 4, and b is equal to plus or minus 2. And similarly, if b squared is equal to minus 9, then b is equal to the square root of minus 9, which is plus or minus 3i. Plus or minus 3i, because you've got a minus there. Okay, so if that's the case, then we can sub all of these back in, okay, and we can figure out what the a value is. So we have a formula for a, it's 6 over b, okay? So if I put a plus 2 in, I get, so at b is equal to plus 2, then a is equal to 3. And when b is equal to minus 2, a is equal to minus 3. So we have 3 or minus 3. And yeah, we have an a and a b. Right, that's quite cool. Okay, so we can pop these back in now. So we could have, let's try and think. So we have a and we have b. So because b is going to be attached, so we're going to have a 3 plus a 2i or 3 minus a 2i. 2 or minus 2. And I don't think we're going to go with a minus 3. We could do, but if I remember correctly, at the very start in that exam, they wanted, what did they want? They wanted, they wanted this, they wanted to be a part of the real numbers or something like that. So that excluded the possibility of having the minus 3i or something like that. So there you go. And that's a tough one. Okay. So that's how you do the equality of those numbers. So hope that helps you, and I hope it gives you a chance to do your work.